Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Welcome back for another deep dive.
Always fun.
Today we're going to be talking about large multimodal agents. And I think this is going to be a really cool one to kind of unpack.
Yeah, really fascinating area.
So to get started, maybe you can just give us like a high-level overview.
Yeah, so large multimodal agents, or LMAs.
Yeah.
It's basically a new frontier in AI research, where AI is not just processing text or images, but starting to kind of understand the world in a much, much richer way through multiple modalities.
Okay, so multimodal, that basically means that these agents can work with, different types of information, like text, images, video, audio, all at the same time.
Exactly. Instead of being limited to just one sense, like just understanding text, these agents have different tools to process all sorts of data.
Right.
So you can think about them as having, different senses.
Okay, cool.
So, for example, an AI that can not only read a recipe, but also watch a cooking video, and then maybe even control a robot chef to actually make the dish.
That's pretty wild.
Yeah.
Okay, so that's a pretty good, like, high-level overview.
Yeah.
Now, to really unpack this, we're going to be looking at this research paper that lays out the landscape of large multimodal agents.
Yeah, this paper is a great kind of roadmap for understanding what are the core components of LMAs.
Okay.
The different types of LMAs that are emerging, and also, what are the kind of mind-blowing applications that they can be used for. So
let's start with the basics.
Yeah.
What are the key components that make up an LMA?
You can think of it as building a really smart robot.
Okay.
You need to give it senses, a brain, the ability to act, and a memory.
Okay, that makes sense.
To learn from its experiences.
Makes sense.
Yeah.
So first up is perception, and that's how the LMA takes in information from the world, right?
Yeah, and the really interesting thing here is that LMAs are moving beyond simply converting everything to text.
Okay.
Instead, they use specialized tools to process different types of data.
Right.
You can think of it as like giving the LMA different senses so it can understand images, videos, and audio in their native forms.
So instead of trying to describe like a video with words, it can actually like see it and understand what's happening.
Yeah.
That's really cool.
Like imagine an LMA learning to play a video game.
Right.
Instead of just processing the game as, a bunch of pixels.
Right.
It can actually learn the visual language of that world.
Okay.
Recognizing objects, understanding their relationships, and even predicting how they might behave.
That's so cool.
Yeah.
So it's like it's learning to see the world the way a human player would.
Precisely.
Awesome.
And that level of understanding opens up a whole new world of possibilities for, how LMAs can interact with and learn from their environments.
Okay, so we've got perception covered. Yeah.
What about planning?
Right.
Sounds like that's the brains of the operation.
Absolutely.
Yeah.
Planning is where the LMA takes all of the sensory information from perception and figures out what to do with it.
Right.
It's like the thinking part of the LMA.
Okay.
Where it reasons, makes decisions, and develops plans to achieve its goals.
So is there like an AI brain in there doing all this?
Not exactly a physical brain, but sophisticated algorithms that are acting as planners.
Okay.
And the research highlights a trend toward using open source models like Llama and Llama.
Oh, those are the ones we hear about all the time now.
Yeah, exactly.
Well,
this planning stage.
So open source is great because it makes this technology more accessible to a wider range of, researchers and developers.
Yes, and it fosters collaboration and innovation in the field.
Yeah.
So
now how does the LMA actually formulate those plans?
Right.
Can't be all pre-programmed, can it?
It's not all pre-programmed. LMAs can actually create plans in two ways. Okay.
Either as natural language,
kind
of like a to-do list,
like a to-do list,
or as program code, which gives very precise instructions.
So it's like giving instructions to a person.
Right.
You could either tell them like in plain English what to do, or you could give them a detailed recipe with like precise measurements and steps.
Yeah, that's a great analogy. And the choice of plan format depends on, the complexity of the task.
Okay.
And the level of detail required.
Makes sense.
But what's really fascinating is how LMAs learn to make effective plans in the first place.
Yeah. Don't they learn?
Right.
Like, do they get better over time?
This is where it gets really interesting. The research highlights the importance of what they call inspection and reflection. Basically, LMAs can learn from their past successes.
So like remembering what worked.
Exactly, remembering what worked
Okay.
and applying that knowledge to new situations.
Got it.
And they can even learn by watching human examples.
So they're building up like a library of experience,
Right.
like humans do.
Exactly.
The more they try, the better they get.
Yeah, as they encounter more diverse situations,
Right.
their planning becomes more adaptable
Okay.
and robust,
Got it.
allowing them to tackle increasingly complex tasks.
Okay, so we've covered how they perceive the world and plan their actions.
Yeah.
But how do they actually act on those plans?
Right.
Do they like have robot arms or something?
That's a great question. So, LMAs can act in different ways depending on their purpose and their environment.
Okay.
So the paper talks about three main types of action:
Okay.
tool use,
Mm-hmm.
embodied actions, and virtual action.
Okay, let's break those down.
Yeah.
What's tool use in the context of an LMA?
Tool use is basically leveraging existing tools to get things done.
Okay.
You can think about it as giving the LMA a toolbox.
Okay.
These tools could be visual foundation models,
Okay.
APIs that allow them to interact with other software,
Okay.
or even, programming languages like Python.
So it's like the LMA can use a hammer or a screwdriver, but in a digital sense
Exactly.
to achieve its goal.
Right.
Okay.
And then we have embodied actions.
Okay.
So this is where the LMA controls a physical robot
Oh, cool.
or a virtual character within a simulated environment.
Okay.
Think about robots navigating a warehouse
Right.
or AI-powered characters in video games.
So the LMA is like the brains behind those actions telling the robot or character what to do.
Right.
Okay, cool.
And finally, there's virtual actions.
Okay.
So this is where the LMA interacts with digital interfaces,
Okay.
such as browsing the web,
Okay.
clicking buttons, or typing text.
So it's like having like an AI assistant
Yeah.
that can navigate the digital world for you.
Right.
That's cool.
Yeah.
But how do these LMAs actually learn to like act effectively?
So similar to planning, there are two main ways: through prompts,
Okay.
which are like instructions from a teacher,
Okay.
or by learning from data, like watching a pro gamer master a particular game.
So it's all about learning by doing either through guidance or by observation.
Right.
Okay.
Yep.
This is all starting to feel really complex.
Yeah.
Yeah. It makes you wonder how an LMA keeps track of everything it's learned and experienced.
Yeah, that's a really important point. And that brings us to the final core component, memory.
Memory. Okay.
Just like humans,
Right.
LMAs need to remember in order to learn and improve.
Okay.
And this is where things get even more challenging.
So does an LMA have like an AI brain with like a little memory bank inside?
Not quite a physical memory bank,
Okay.
but again, sophisticated algorithms that allow LMAs to store and retrieve information.
Okay.
The paper distinguishes between short-term memory,
Right.
which is used for immediate tasks,
Uh-huh.
and long-term memory,
Yeah.
which is crucial for more complex reasoning and decision-making over time.
So it's like the difference between remembering what you had for breakfast this morning
Right.
versus remembering your childhood memories?
Yeah, that's a great analogy.
Okay.
So short-term memory is like a mental scratch pad for current tasks,
Got it.
whereas long-term memory is this vast storehouse of knowledge and experiences.
Right.
And because LMAs deal with so many different types of information,
Right.
figuring out how to effectively store and retrieve all of that data is a major challenge.
It's like trying to organize a library with books and movies and music and photos all mixed together.
Exactly, and that's one of the key areas of research in the field of LMAs.
Right.
Developing, efficient and effective memory systems that can handle the complexity of this multimodal information.
Okay, so now we have a good understanding of like the 4 core components of an LMA.
Right.
Perception, planning, action, and memory.
Yeah.
But I'm curious, how are these components combined in different types of LMAs?
Right.
Are there like different flavors, so to speak?
Yeah, there are different types of LMAs,
Okay.
each with its own strengths and limitations.
Okay.
And the research paper actually proposes a taxonomy of LMAs, categorizing them into 4 distinct types based on how they utilize planners and memory.
Okay, I'm ready to explore these different LMA types.
All right.
What's the first one on the list?
The first type is what we might call early LMAs.
Okay.
They rely on closed source LMMs
Okay.
as their planners,
Uh-huh.
and they don't have any long-term memory.
Okay.
You can think of them as the first generation,
Okay.
laying the groundwork for more advanced systems.
So they're like the interns of the LMA world.
Exactly.
Yeah.
They're great for basic tasks like image editing or visual question answering,
Right.
but they're not quite ready to handle more complex challenges that require reasoning
Okay.
or learning from experience.
Got it.
Yeah,
So what about the second type?
right.
How do they differ from these early LMAs?
Type 2 LMAs also lack long-term memory,
Okay.
but they leverage fine-tuned LLMs as planners, often using open-source models.
Right.
This makes them more accessible and adaptable, but still limited in their ability to handle, really complex scenarios.
So they're like the next step up from interns, maybe more like junior employees
Yeah, that's a good way to think about it.
with some specialized skills.
Exactly.
Yes.
So the first two types are still relatively basic, lacking that crucial element of long-term memory.
Yeah.
What about the third type? How do they incorporate memory into the mix?
Type 3 LMAs are where things start to get really interesting.
Yeah.
They introduce this concept of indirect long-term memory,
Okay.
which means that the LLM, acting as the planner, doesn't directly interact with memory.
Okay.
Instead, it uses tools to access and retrieve information from a separate memory system.
So it's like it has an assistant that fetches files from a library for it.
Yeah, that's a good analogy.
Okay.
So the LMM is still calling the shots,
Right.
but it relies on these tools to handle the memory management.
Okay.
Yeah.
The paper mentions like an example of a video processing LMA
Right.
that uses this method. Yes. So this LMA is like an AI detective piecing together clues from a security camera.
Okay.
It uses tools to query a memory bank for spatiotemporal attributes.
Right.
Things like what objects were present in a scene,
Okay.
where they were located,
Uh-huh.
and how they moved over time.
Got it.
This allows it to understand the video content in a more sophisticated way.
So instead of just seeing like a bunch of moving images, it can actually understand like
Right.
the context and meaning behind those images.
Yeah.
That's really cool.
And this type of indirect memory access allows Type 3 LMAs to tackle more complex tasks than their predecessors.
Okay.
But
the most advanced type 4,
right.
takes memory integration to a whole new level.
Yeah, Type 4 LMAs are the superstars when it comes to memory.
Okay.
They feature planners that directly interact with long-term memory
Okay.
without needing any intermediary tools.
Okay, so no more waiting for the assistant to fetch those files.
Exactly.
Okay.
So it's like the LLM has its own internal library
Right.
that it can access instantly.
So that must make them super efficient.
Exactly. This direct access allows for much faster and more efficient memory retrieval,
Right.
enabling these LMAs to exhibit even more sophisticated and intelligent behavior.
Okay.
Remember that Minecraft example we talked about?
The one where the LMA was like a master gamer recalling past successes to like dominate the game?
Yes, that was a Type A LMA.
Cool.
It could recall past successful plans
Okay.
and the initial states that led to those successes.
Okay.
This allowed it to very efficiently complete new tasks by drawing on its experience.
Okay, so it's like the difference between an AI assistant that needs to remember all your preferences and they have to call their assistant to fetch each file
Right.
versus the AI just has all that info in their head ready to go.
That's a fantastic way to put it.
Okay, cool.
Yeah, so Type A LMAs are like the seasoned experts of the AI world,
Awesome.
with a vast library of experience at their fingertips.
Wow, this is incredible.
Yeah.
We went from basic interns to like expert level AI
Right.
in just a few minutes.
Yeah.
It sounds like we're on the verge of some truly like remarkable advancements in AI with these different types of LMAs.
We are, and it's not just about individual LMAs getting smarter.
Yeah.
The research also explores how these agents can work together
Okay.
to achieve even more amazing things.
Wait, you mean like teams of LMAs collaborating?
Yeah, imagine a group of LMAs,
Okay.
each with its own specialized skills and knowledge,
Right.
working together like a well-coordinated team.
Okay.
That's the idea behind multi-agent frameworks.
So instead of one LMA trying to do everything, they can divide and conquer,
Right.
each focusing on what they're best at.
Exactly. Some LMAs might specialize in perception, while others focus on planning or action by working together.
Got it.
They can tackle much more complex tasks than any single LMA could handle on its own.
That's amazing.
Yeah.
It's like having a dream team of AI experts all working together
Yeah.
to solve a problem. The paper mentions an example of this called the Memodroid framework.
Yes. Memodroid is designed for automating tasks on mobile devices.
Okay.
So imagine having a team of AI assistants working together
Okay.
to manage your phone,
Right.
scheduling appointments,
Right.
responding to messages,
Yeah.
even ordering food.
That would be amazing.
Yeah.
It sounds like we're on the cusp of a world where AI can handle all of those like tedious tasks,
Right.
freeing up our time and energy for more important things.
Absolutely.
That's awesome.
And that's just one example of how multi-agent collaboration
Right.
is pushing the boundaries of what's possible with LMAs.
Okay.
But before we get too carried away with all of these exciting applications,
Right.
there's one more aspect we need to consider.
Okay. Is there like a catch?
Well, not a catch, but a crucial question we need to address.
Okay.
How do we know if an LMA is actually good at its job?
Right. Right.
How do researchers evaluate these systems?
That's a really important point. We can't just assume they're doing a good job just because they're AI.
Exactly. The paper dedicates a whole section to evaluation,
Mhm.
and it highlights two main approaches:
Okay.
subjective evaluation
Okay.
and objective evaluation.
So subjective evaluation is like getting a human perspective
Yeah.
on how wide an LMA performs.
It involves having humans assess the LMA's capabilities in a more qualitative way.
Okay.
Think about things like versatility.
Okay.
How well can the LMA use different tools
Hmm.
and handle various tasks?
Right.
User friendliness.
Okay.
How easy is it to interact with
Yeah.
scalability?
Uh-huh.
How well can it adapt to new challenges and learn new things?
Right.
And also value and safety.
Okay. So it's like having a panel of judges assess the LMA's performance
Exactly.
based on all these different criteria.
Yeah.
Okay. What about objective evaluation?
Objective evaluation focuses on measuring performance in a more quantifiable way,
Okay.
using specific metrics and benchmarks.
So like giving it a test and grading it.
Yeah,
Okay.
exactly. So for example, if
Yeah.
an LMA is designed to answer visual questions,
Okay.
we can measure its accuracy.
Okay.
How often does it provide the correct answer?
Makes sense.
Yeah. But the paper does mention some challenges with using traditional task-based metrics
Okay.
to evaluate LMAs.
What are those?
Yeah, that's because traditional metrics often fall short in capturing the complexity of what LMAs are capable of.
Okay.
So imagine trying to evaluate a system
Yeah.
that can understand images, reason about them, and take actions based on that understanding.
Right.
You need more nuanced metrics than simply measuring accuracy on a single task.
It's like trying to judge a figure skater just based on how high they can jump.
Exactly.
There's so much more to it.
Yeah, so the field is still working on developing better evaluation methods that can truly assess the full potential of LMAs.
Makes sense.
But even with these evaluation challenges,
Yeah.
there's no denying that LMAs are already having a significant impact across a wide range of applications.
Okay, this is what I've been waiting for. Let's dive into those applications.
All right.
And see what these LMAs can actually do in the real world.
Get ready to have your mind blown.
Okay.
We're about to explore a world where AI is not just a concept in a research paper, but a powerful force transforming the way we live,
Right.
work, and play.
Let's do this.
All right, so we've covered, a lot of ground.
Yeah.
From the basic building blocks of LMAs
Yay.
to the different types and how they're evaluated.
Right.
Now let's kind of shift gears and explore the exciting world of LMA applications.
I'm ready to have my mind blown.
All right.
Where do we even begin?
Well, let's start with something that many of us can relate to.
Okay.
GI automation.
Okay.
Imagine an AI that can handle all of those tedious tasks you do on your computer every day.
Okay, I'm listening.
Yeah, you're talking about.
Things like scheduling meetings, filling out forms, organizing files, all that stuff that takes up so much time and mental energy.
LMAs are being used to create intelligent assistants that can automate these tasks, making our digital lives much smoother and more efficient.
So instead of spending hours wrestling with spreadsheets
Right.
or clicking through endless menus,
Exactly.
we could have an LMA handle it all for us.
That's the idea.
That would be amazing.
Yeah,
Are there any real-world examples of this already happening?
absolutely.
Oh,
One example is GPT-4v Act,
okay.
which combines the power of GPT-4v with web browsing capabilities.
Okay.
It can make user interfaces more accessible
Okay.
and automate complex workflows.
So it's like having a super smart assistant who can not only understand your instructions,
Right.
but also navigate the digital world to get things done.
Exactly.
That's incredible.
Yeah.
So LMAs aren't just a futuristic concept. They're
No.
already making our lives easier today.
Absolutely. And that's just the beginning.
Okay.
Now imagine taking this a step further
Okay.
and applying it to robotics.
Okay. Robots powered by LMAs.
That sounds like something straight out of a sci-fi movie,
It does.
but it's becoming a reality. Traditional robots often struggle with tasks
Right.
that require real-world understanding and adaptation.
Okay.
They're good at repetitive tasks
Right.
in controlled environments,
Yeah.
but they can't really think for themselves.
Right, like those clunky factory robots.
Exactly.
Yeah.
But with LMAs, robots could become much more intelligent and adaptable.
Okay, so how would that work?
Well, LMAs can equip robots with multiple senses,
Okay.
vision, touch, even sound,
Okay.
to perceive and interact with their environment in a much richer way.
So we're not talking about those clunky factory robots anymore. These are robots that can actually understand their surroundings and make decisions
Exactly.
based on what they perceive.
Researchers are already using LMAs to develop robots
Okay.
that can perform a wide range of tasks, from navigating complex environments
Okay.
to interacting with objects and even humans.
Okay, cool.
Yeah.
Are there any specific examples you can share that really showcase the power of LMAs in robotics?
One compelling example is a system called MP5,
Okay.
which is being used to kind of demonstrate this potential of embodied AI
Okay.
powered by LMAs, and they're doing it in Minecraft.
Wait, Minecraft, the video game?
Yes, Minecraft is actually a fantastic testing ground for AI research
Okay.
because it's a complex virtual world
Right.
with a lot of rules and possibilities.
I've always said that about Minecraft, actually.
It's a great platform.
It's a really good training ground.
Yeah. And this MP5 system can break down complex tasks into smaller steps,
Okay.
actively perceive its environment,
Okay.
and even learn from its experiences.
So it's like having an AI agent
Right.
that's learning to navigate and interact with the world,
Exactly.
just like a human player would in Minecraft.
Precisely. And the skills that these AI agents learn in virtual environments like Minecraft
Right.
can then be applied to real-world robotics,
Oh, okay.
making them more capable and adaptable.
Wow, that's fascinating.
Yeah.
Okay, so we've covered UI automation and robotics. What other industries are being transformed by LMAs?
Well, one area where LMAs are making a huge splash is game development.
Okay.
Get ready to say goodbye to those frustratingly predictable game characters,
Okay.
and hello to a whole new level of immersive gaming.
Okay, now you're talking my language.
Yeah.
I've spent countless hours battling those brainless NPCs in video games.
Right, those non-playable characters.
Yes,
They can be pretty frustrating.
they can be.
So LMAs are enabling game developers to create characters that are more intelligent,
Okay.
more responsive, and more engaging.
Okay.
Imagine playing a game where the characters learn from your playstyle,
Oh, wow.
adapt their strategies,
Okay.
and even surprise you with their actions.
That would completely revolutionize gaming.
Right. It would be like playing as real people.
Yeah, but with the added benefit of knowing they were designed to provide a challenging and entertaining experience.
Exactly.
That's cool.
And researchers are already developing benchmarks and testing platforms to push the limits of LMA capabilities in these game-like settings.
So it's like they're creating a training ground for the next generation of super smart
Yeah.
game AI.
Exactly.
Okay.
And as these AI agents get better at playing games, they're also developing valuable skills
Right.
that can be applied to other areas like problem solving,
Right.
strategic thinking, and even decision-making in complex situations.
Okay, so we've got robots that can play Minecraft
Yeah.
and game characters that are smarter than ever.
Right.
What else is on the LMA horizon?
Well, hold on to your seat because we're about to venture into the realm of autonomous driving.
Okay, self-driving cars.
Exactly.
They've been in development for a while now, so what's so different about the LMA approach?
Traditional self-driving systems rely heavily on pre-programmed rules and sensor data.
Okay,
They're good at following lanes
right?
and detecting obstacles, but they struggle with the nuances of human driving.
So they lack that human intuition and flexibility to
Yeah.
handle unexpected situations.
But LMAs can go beyond that,
Okay.
using their multimodal understanding to reason about their surroundings,
Okay.
predict potential hazards, and make decisions that prioritize safety and efficiency, just like a skilled human driver.
So they're not just reacting to what's happening.
Right.
They're actually anticipating and planning ahead.
That's the key difference.
Okay.
And researchers are already developing LMA-powered driving systems that can handle complex driving scenarios.
Okay.
From navigating busy city streets
Wow.
to merging onto highways
Okay.
and even making split-second decisions to avoid accidents.
That's incredible.
Yeah,
It sounds like LMAs could make our roads much safer and more efficient.
they have the potential to.
Yeah.
Yeah.
Are there any specific examples of LMA-powered driving systems that are particularly impressive?
One notable example is GPT Driver,
Okay.
which uses a language model to plan driving trajectories.
Okay.
It doesn't just rely on sensor data.
Okay.
It also takes into account things like traffic laws,
Oh,
road conditions, and even the behavior of other drivers.
so it's like having a super smart AI co-pilot that's constantly analyzing the road and making strategic decisions to ensure a safe and smooth ride.
That's a great way to put it.
Yeah.
And as these systems continue to develop,
Yeah.
we could see a future where human drivers become a thing of the past,
Wow.
replaced by AI that's far more capable and reliable.
Okay, I'm officially mind blown.
Yeah.
We've covered GUI automation,
Yeah,
robotics, game development, and now autonomous driving.
that's a lot.
It is a lot.
Yeah.
Are there any other areas where LMAs are making a significant impact?
Oh, there's so many.
Okay.
We could spend hours talking about video understanding, where LMAs are being used to analyze and interpret video content in fields like security, entertainment, and education.
Oh,
Or we could dive into visual generation and editing,
okay.
where LMAs are becoming powerful tools for creative professionals,
Right.
allowing them to create and manipulate images and videos with incredible ease.
Those sound like game changers in their own right.
Yeah, they are.
It's amazing to see how LMAs are being applied across such a wide range of fields.
Yeah, it really is.
But I'm curious, are there any applications that are pushing the boundaries of LMA capabilities even further,
Yeah,
tackling more complex and challenging tasks?
absolutely. The research also highlights some cutting-edge applications in areas like complex visual reasoning tasks
Okay.
and audio editing and generation.
Okay.
This is where we start to see the real cognitive power of LMAs coming into play.
Okay, let's dive into those.
Yeah.
What kind of complex visual reasoning tasks are LMAs capable of handling?
Well, imagine asking a question that requires understanding both textual and visual information.
Okay.
Like what type of bird is perched on the branch in this picture?
Okay.
Or even more complex queries like find me a video clip that shows a person riding a bicycle through a park on a sunny day.
Those are definitely complex tasks that require a deep understanding of both language and visual content.
Right.
Are LMAs actually able to do that?
Yes. Researchers are developing LMAs that can handle these types of complex visual reasoning tasks.
Wow.
They're essentially creating AI systems that can see and understand the world
Okay.
in a way that's similar to how humans do.
That's incredible.
Yeah. It's like having an AI research assistant
Right.
that can sift through vast amounts of information, both textual and visual,
Yeah.
and extract the key insights.
That's really cool.
And these systems aren't just limited to retrieving information.
Right.
They can also generate creative content based on this fusion of textual and visual inputs.
So they could write a poem about a picture,
Exactly.
compose music inspired by a painting, or even create a short film based on a series of photographs.
The possibilities are endless
Wow.
when you combine the power of language and vision.
Yeah.
And this is just the beginning.
Right.
As these systems continue to develop, they could revolutionize fields like scientific research education, even journalism.
Imagine AI systems that can help us analyze complex data, uncover hidden patterns, and communicate those findings in a way that's both informative and engaging.
It's amazing to think about.
The potential is truly mind-blowing.
It is. And
Yeah.
speaking of mind-blowing potential, let's not forget about the incredible advancements happening in audio editing and generation thanks to LMAs.
Okay, tell me more about that.
Yeah.
I'm always fascinated by the intersection of AI and creativity, especially when it comes to music.
LMAs are being used to compose music, create sound effects, and even mimic human voices
Okay.
with astonishing accuracy.
Wow. So they can basically create any sound imaginable.
Pretty much researchers are developing LMAs that can generate everything from realistic sound effects for movies and video games
Okay.
to entire musical compositions in a variety of styles.
It's like having an AI orchestra at your command,
Right.
ready to create whatever sound you can dream up.
Exactly. And this technology is already being used
Wow.
in a variety of creative applications, from music production to film scoring, and even personalized soundscapes for relaxation or focus.
I I think I need a moment to process all of this.
Yeah, it's a lot to take in.
We've covered so much ground today.
We have.
From those basic building blocks of LMAs
Right.
all the way to these incredible applications that are transforming entire industries
Yeah.
and pushing the boundaries of what we thought was possible with AI.
Ooh, it's really exciting to see.
It is.
I think the key takeaway is that LMAs are still in their early stages of development,
Okay.
but they're already showing remarkable potential.
Yeah.
They're not just a cool research topic.
Right.
They're a powerful force that's shaping the future of technology and our relationship with it.
I completely agree. It feels like we're on the cusp of a major technological shift.
Yeah,
And I'm both excited and a little bit intimidated by what the future holds.
I understand that feeling. It's important to approach these advancements with a sense of both wonder and caution.
Yeah.
I don't know.
Now, before we wrap up this deep dive, I'm curious to hear your thoughts on the future of LMAs. Where do you see this technology heading in the next 5 to 10 years?
That's a great question,
Yeah,
and one that's difficult to answer with any certainty.
of course.
But if I had to speculate, I think we'll see LMAs becoming increasingly integrated into our daily lives,
Okay.
both in visible and invisible ways.
Okay.
We'll likely interact with LMAs through our smartphones, our computers,
Right.
even our homes and cars.
So, a future where AI is seamlessly woven into the fabric of our lives,
Exactly.
anticipating our needs and helping us navigate the complexities of the digital world.
And I think we'll also see significant advancements in the capabilities of LMAs,
Okay.
particularly in areas like natural language, understanding common sense reasoning,
Right.
and long-term memory.
Okay.
They'll become more intuitive,
Mm.
more adaptable,
Right.
and capable of learning and evolving over time.
So, LMAs that are not just smart, but also understand us on a deeper level.
Right.
Almost like having a truly intelligent companion by our side.
It's a compelling way to think about it, and perhaps most exciting of all.
Okay.
I think we'll see LMAs being applied to tackle some of the world's most challenging problems
Okay.
in areas like healthcare,
Okay.
climate change, and sustainability.
That's a future I can definitely get behind.
Yeah.
Imagine AI that's not just making our lives easier, but actually helping us solve some of the biggest challenges facing humanity.
It's an inspiring thought.
It is.
And I believe that LMAs have the potential to make a real difference in these areas.
Okay. I'm feeling a mix of excitement and awe right now.
Yeah.
This deep dive has been an incredible journey.
It has.
It really does feel like we're on the brink of something huge with this technology. But, you brought up something important earlier, and I think it's worth kind of revisiting before we wrap up. It's not all just about the wow factor, right?
You're absolutely right. As with any powerful technology, there are considerations to keep in mind as LMAs become more advanced and, more integrated into our lives.
Yeah, I'm thinking about like the impact on things like jobs and the economy if AI can automate so many tasks.
That's a valid concern, and it's something that researchers and policymakers are actively discussing. As LMAs become more capable, it's important to think about, how we can ensure that everyone benefits from these advancements.
So it's not just about developing the technology, it's about considering the societal implications
Right.
and preparing for those changes.
Exactly. It's a complex challenge, but it's crucial to have these conversations now so we can create a future where LMAs contribute to a more equitable and prosperous society for everyone.
Yeah, okay, that makes sense. It's a reminder that we need to be thoughtful and responsible
Right.
in how we approach this technology.
Well said. And I think this deep dive has given us a lot to think about, both in terms of the exciting possibilities and the challenges we need to address.
It definitely has. I feel like I've gained a much deeper understanding of this field, and I'm even more excited to see how it continues to evolve.
Me too. And for our listener, if you're as fascinated by this topic as we are, we encourage you to check out the research paper we've been discussing. We'll include a link in the show notes.
Yeah, it's a great resource for anyone who wants to kind of dive deeper into the technical details and explore the full scope of LMA research. Who knows, maybe you'll be inspired to contribute to this exciting field yourself.
That would be fantastic.
Yeah.
We need bright minds from all backgrounds to help shape the future of AI and ensure that it's a future we can all be proud of.
Well said. And on that note, I think it's time to wrap up this deep dive into the world of large, multimodal agents.
It's been a pleasure exploring this fascinating field with you.
As always, thanks for joining us on the deep dive. Until next time, keep exploring, keep learning, and keep asking those big questions.